So thank you for coming today. Bill and I will be talking about architecting for end-to-end security in the enterprise from the perspective of security solutions architects and the professional services organization at AWS. I work within that professional services organization as a principal consultant, and I lead our enterprise security risk and compliance practice. The mission of ProServe is to engage with our enterprise customers to build confidence and capability on our platform. And the way we do that is by helping you operationalize the shared responsibility model, right? Take a lot of the best practices and principles that you read about or you're developing patterns around and help you implement them, right? To really accelerate your ability to effectively adopt AWS. What we're going to talk about today is the journey that security organizations take as they adopt AWS for their organization. And it's a journey that doesn't always start at the beginning, often starts in the middle, driven by a particular use case or workload, and then has to sort of fan out across the enterprise to be something that's scalable and sustainable, and that will work across a variety of environments. And what I'm continually reminded of as I engage with chief security officers is that the security architecture element of the journey is just one activity that is the basis for a solid enterprise security program in the cloud. And that what's really important to them is to be able to develop frameworks and processes that are repeatable, that allow them to plan for the future of security while implementing some very important tactical mitigations today as part of their workload migration. And so part of that means really coming to the realization and understanding that security architectures and the patterns and the very, very specific implementation activities that you've seen in probably other talks at reInvent this week in the security and the architecture track really have to exist in the broader context of an enterprise where you have system and software development life cycles, where you have risk management frameworks, where you have regulatory requirements, and all of that has to be kind of folded around the way that you layer on your defense in-depth architecture and you conduct your journey. So with that as a basis, we're going to talk principally about four things today. We're going to talk about enterprise security strategy and how to integrate AWS into that in your organization. We're going to talk about how you deploy defense in depth through an architecture that covers not only defense in depth, but at times defense in breadth as well. We're going to look at ways to convert your strategy into tactics, developing security operations playbooks that give you that repeatable process outside of automation so that your people can effectively work in this environment. And then we're going to identify some very specific use cases and call them out and go a little bit deeper so that you can understand how the strategy, how the architecture, and how the playbook end up operating in a real-world scenario. So to begin, we're going to talk a little bit about the strategy. And strategy tends to have two components. It's the chief information security officer and their staff's ability to begin to leverage some of the economies of scale and scope that you encounter in AWS on the security and risk management level, and then the value of taking time up front to integrate these things into your security strategy as an enterprise. So first and foremost, one of the things that we like to remind everybody of is that everybody who's a customer of AWS gets that same high bar of security features and compliance, right, with every single deployment that you have. So when we have a particular assurance framework that we can demonstrate compliance with, whether it's ISO 27001 or the ability to publish a SOC 1 or SOC 2 report, right, you get that as a customer of AWS with every single deployment. Part of what that means is that you get a reduced compliance scope, right? You're able to inherit a lot of those features and characteristics and then focus on really just tailoring the control sets and the documentation necessary for your specific workload, right? What you're also able to do is leverage defense in depth at a very, very precise level in terms of layers and leverage the variable cost nature of operating in the AWS environment, right? So what you can do is you can truly scope the types of mitigation and the types of protection mechanisms you need and have them grow with the deployments and have them scale out horizontally, just as you would any other workload, right? And finally, security truly benefits from automation. In a traditional enterprise security environment, there's a lot of manual processes, there's a lot of manual tabulations, right? Lots of spreadsheets, lots of counters, and In the AWS environment, you truly benefit from the idea that infrastructure is deployed as code, and so it's very document-driven. You have the ability to version control, you have the ability to mark up, and you have the ability to control access to essentially every element in your environment and have complete transparency to every asset and every control feature that's been deployed, all at scale, right? All automated. So there's a lot of really nice benefits when you're thinking about developing your strategy and how you're going to fold those in from the perspective of an enterprise security deployment. I mentioned earlier that we often are engaging in workload deployment with enterprise customers. And what will sometimes occur is that you feel like you're walking into the middle of a conversation, right? You're presented with a series of security requirements that are derived from certain compliance regimes or assurance frameworks. And you're asked to select very specific controls for that particular workload to demonstrate as a proof of concept that something can run securely in the AWS environment, right? Many of you in the audience today probably have that experience, right? It's very, very tactical. But the role of a chief information security officer and their staff is really to think about the impact of the entire enterprise and make good risk-based decisions, right, to do things at scale. And so what we find is that by taking a step back in some cases while the deployment is ongoing and saying, how can we take the lessons learned from those specific control objectives and answer some more fundamental questions that are really being asked in piecemeal, control by control. So how do we adapt to operating in the cloud securely? Right? How do we adopt the right controls to give us the confidence that we're doing the right things? And then how do we innovate on top of that, right, to be able to best position our businesses for success in the enterprise? It's a fundamental role that the strategy plays. And one of the other things it does is it prevents you from having to worry about the vacuum that's created by a lack of direction. So what we find is that as soon as a security organization is able to not only provide some compliance or some prescriptive guidance in terms of security patterns, but also to be able to provide the vision for what's the desired end state, what's our concept of operations, what types of patterns do we find acceptable in our environment, how are we going to test against those programmatically across the enterprise. What you find is that a number of different workloads immediately become available, and people move from a position of assuming that the security organization isn't prepared to adopt the cloud to a position that understands what the roadmap is and how the chief security officer plans, right, to move into that environment and to be able to be a partner in that journey, right, which is very, very important. So what I'm going to do is I'll turn the conversation over to Bill for a little bit. He's going to talk about the capabilities framework, and then we're going to move into a deeper dive into defense in depth architecture.
Thanks. So thanks for coming today. My role as a security solution architect is to help customers map our features into their existing security programs. So this next part of the talk will be about what we've learned from engagements, from working with customers like you, and how you manage your security programs around the things you're trying to achieve as an organization. Then I'll hand it back to Hart to talk about defense in depth. So what we have is an example. This is just an example of a security capabilities framework. So like we heard about in the keynotes and last year at reInvent from Jeff, was that we innovate around things that are always important to customers. So these things have been true since kind of the dawn of time in terms of protecting information. You want to anticipate the threats, you want to deter them, you want to be able to respond and recover. So your organizational capabilities matrix, you might have an enterprise security strategy, includes some boxes. It might have 3 boxes, might have 12 boxes, but it probably has some boxes. This is a cross-section of what we've seen from customers, and we'll use it kind of as talking points today to walk you through how to map AWS security features and functions into an existing capability matrix. So let's start with anticipating. And anticipating can mean a few things. It can mean anticipating regulatory compliance. It can mean anticipating threats and attacks on your infrastructure. But the important part is you start with anticipating. It's really the plan part of security strategy. And that can include everything from policies and standards. So think about the last time you went through an audit and how fun that might have been for everybody in the room, right? So when you go through an audit, think about how you do that in the organization. How are you going to work with people that you work with, that you depend on for information? How are you going to structure the information? How are you going to present it to your auditors or your regulators or your customers upstream from you? So anticipating how you're going to do that before you begin architecting is absolutely critical. So this is what we use as kind of a building block approach. So Amazon Web Services has lots of building blocks, and this is just one way to organize the information in terms of maybe an enterprise architecture. Maybe you have an enterprise architecture working group in your company or in your enterprise. Most enterprises do. And what we'll do is allow you to kind of think about how you can map these features, functions, and services into that enterprise architecture or security strategy that you have to achieve the capabilities we just discussed. So let's start with just some examples. Now, we don't have hours and hours today, so this is what we do as architects and professional service folks, is go on site or get engaged with customers to help a deeper conversation around this. But we'll give a few examples of how we can map some of these features and functions into the capabilities. So let's start with AWS certifications. So when I talked about preparing for an audit, there's some things you're responsible for and some things we're responsible for. So knowing and becoming intimately familiar with our certifications, ISO 27001, or our alignment to NIST 853, or PCI DSS, knowing what the subcomponents of those certifications actually include gets you a really long way toward meeting an audit and regulatory requirements of your own. Think about lifecycle rules. So just storage lifecycle rules. Very simple, feature of S3. You can use EBS snapshots. There's a bunch of ways to achieve lifecycle management of data on AWS depending on the service. But the important part is to think about lifecycle rules and how you can use them to achieve recovery later on if things go wrong, or how to meet retention schedules and retention requirements. And those are features in many AWS products where you have some ability to manage the lifecycle of your data. Let's kind of focus on Deter. And this would be things like active security or more passive security, things that are hard protective type controls where you're actually preventing actions, things like identity and access. We'll use a couple of examples to show how you can align the preventive controls and the deterrent controls in AWS features and services to meet the capability framework. Again, same slide, different orange boxes relevant to the things that fit this part of the capability. So when these slides are available, it's a good place to start. Talk about SSH keys. Very simple. Anybody who's used EC2 is familiar with how we can put an SSH key into, say, a Linux instance and allow you to authenticate against that host. Simple integrations, though, but when you try to demonstrate how you're achieving your control objectives or how you're meeting your security capabilities that you do in a traditional environment, but you're doing it on AWS today, it's very familiar, right? We help you get SSH keys into instances. But in terms of representing how you can satisfy an audit, for example, it's no different, but understanding how that works in AWS ahead of time is pretty critical. Security groups. Understanding that this is a stateful layer 4 firewall, very familiar, but again, demonstrating deterrent controls, mapping it to your capabilities, and using that as an example, you can see how you'd map the other capabilities or features together to create a security strategy, security architecture that's really end-to-end. Identity and access management, users, groups, and roles. Been quite a few talks about identity and access management today, or at reInvent, and we'll talk about some specific operational examples later in the talk. But again, thinking about this and planning ahead and mapping it into your capabilities ahead of time, how do you want to provision users? How do you want to provision roles? What kind of entitlements do they want to have? How can you reuse policies? Those things are critical when you're planning your security strategy. Redshift Cloud HSM support. Just a recent feature that we've announced in the last week or so. Allows you to manage keys in Cloud HSM so that you have durable, tamper-resistant, tamper-evident storage of keys, but still integrate your management of the keys with data in Redshift. So again, it's a preventive control for data at rest encryption and allows you to plan ahead, meet regulatory requirements, meet your internal control objectives using strong cryptography. Let's talk about detection. So these are the features and functions that we feel provide you some capability to accelerate the detective controls in your enterprise. So as a former manager and person who had to run security event management software, I really love the features in Amazon Web Services that help detective controls. Let's talk about CloudTrail, a service we recently launched that gives you very fine-grained user activity auditing of API access. This to me is a security accelerator that I'm very excited about. To be able to get all that information and security logging information up and down the stack in one place is very empowering to people who have to do log management and security event monitoring with AWS in mind. Think about what it takes to get logs for the operational activities on a router or a switch or a storage device all in one place. If you manage SIMs, if you're a log management person, you know exactly what I'm talking about. That's kind of a hard problem in a traditional IT environment. I think the CloudTrail makes that demonstrably better. Elastic MapReduce and Amazon Redshift. I'm a big believer in security goes first. So when we talk to customers, we have a lot of security conversations. It's often the first conversation we have. And I challenge people. I say, let's have your security teams work to get their workloads first. It's often not the regulated data. It allows and empowers the security team to go first and get comfortable with Amazon Web Services before the rest of the business comes asking, how do I do this? How do I do that? How do I meet this control objective? But if security goes first and uses things like MapReduce, Elastic MapReduce, or Amazon Redshift to analyze their security logs and get detective information about the environment using those services, it empowers the security team and accelerates adoption of AWS within the enterprise. And again, it allows you to align to a control framework or to a capabilities matrix as well. And the Security Operations Center, again, not necessarily an AWS feature. It's something you hopefully have in your enterprise. Most enterprises do. You want them at the table. You want them to integrate AWS into their capabilities. They serve a vital role in the organization, and you want them to have integration both in terms of operational procedures and awareness of what's happening on AWS. Critical part of your security capabilities when you use Amazon Web Services. Response. So if there's indicators of compromise, you want to know about it. These are the features we feel like can help you understand, respond, and understand and respond. Resource tagging. So why do I put this in this category? I feel like it allows you to, you can use resource tagging and put tags on Amazon Web Services objects to give more information to the operators who are responding to an incident, whether that's an availability or a security incident, tagging things for how important they are to the enterprise, the order in which they should be recovered, the business line that's responsible for making security decisions for that asset. I really feel like the key part of response is getting more information about those assets. AWS Support plays a vital role in your response. If you have a security incident and have a support relationship with Amazon Web Services, we're here to help. Understanding how you can leverage AWS Support in your operational responses or in your incident response is something you want to plan ahead for and map into your capabilities. And recover. So again, the capabilities we find help you recover your business. So you've tagged your resources. You've thought about lifecycle policies ahead of time, and now you need to recover your business. Using snapshots and replication along with those lifecycle policies and tags can help you bring and recover your business when things go wrong. And geographic diversity, planning to move your workloads to another region, taking into account multiple availability zones when you architect your solutions. That's what we mean by geographic diversity. It's a key part of recovery if there's natural disasters or particular problems with your applications or your workloads in one region. I'll turn it back over to Hart.
Cool, thank you. So as we talk about first developing, articulating, communicating your strategy, and then beginning to map the various features that are available natively in the AWS environment to your particular control objectives, the next thing you want to start to do is actually layer that into an architecture that can ultimately be coded up and deployed, right? There's in CloudFormation, OpsWorks, Chef, however you're going to accomplish that. And ordinarily, the first question that we get asked after that control mapping is, we now understand the features and functions. We understand how to map that into the capabilities framework. We already have literally 50 or 60 on-premise enterprise security products that we're used to using, that we're comfortable using. And question one is always, can we continue to use those in conjunction with the AWS environment as we extend out into the cloud? And uniformly, the answer is yes. There's a tremendous amount of value in maintaining and operating those on-premise enterprise security products. And the second question that you would naturally think of is, well, how many of those can I deploy into AWS, right? How well do they function? What are the licensing implications associated with that? And this is where you've got to fall back a little bit on that capabilities mapping and make some good decisions, right, about how many of those products, although they could and perhaps would operate well in AWS, are obviated by the native features of the platform, right, where you've got some baked-in security functionality that's going to more than meet your needs, and then you can layer those things on instead of at the infrastructure layer. You can layer them on perhaps at the application layer, or to achieve other control objectives. The other thing we learn about as we have this defense in depth architecture model is that you really want to start peeling that onion back layer by layer and think about it in a fairly strategic fashion. The very first layer in that is your network protection strategy, right? Right out of the gate, if you're deploying into VPC, you have a number of sets of controls that you can implement to begin to build out your enterprise security architecture in the AWS environment and make fundamental decisions around governance, right? Do I have one VPC per AWS master account and lots of master accounts? Do I align my account structure by project or line of business? Do we have larger VPCs with enclaves that are separated by subnets and threat management layers, so you achieve both defense in depth and defense in breadth within a single provision deployment? You start to make a lot of these decisions, but at its core, you're still doing many of the things that are so familiar to you in a data center security environment. You've got to build up a routing table that supports your security strategy. You've got to implement network access controls. You have the ability to control the subnetting, right? And how you're going to build out that enclave environment. Right? This is a good first place to start thinking about your logical information model, right? It's an excellent complementary set of workflows and diagrams and architectures that talk to you about how the workloads are going to operate in your environment so that you understand how to not only configure and deploy, but how to protect them at that network layer. The second thing you'll want to do once you have your infrastructure deployed and you've got those right first sets of protections in place is think about the assets that you're going to be provisioning into that environment. And in this particular case, we'll just talk about EC2. So if you think back to what Bill was saying about the control mapping, right? Here's an opportunity that as you deploy instances, you're going to want to think about the variety of security groups and how you're going to attach them, what roles various instances play, and the security groups that should be affiliated with them. Right? And then some of the EC2 specific control features that you might choose to employ, whether it's instrumenting them with CloudWatch or a particular mechanism you want to use to manage any secrets associated with the instance or the application. And often, what we find is that there's some additional information that will really enrich that cycle. So the first pro tip I'll give you is when you get to the point in an enterprise security architecture where you're really talking about deploying assets and modeling them and illustrating them, right? Pro tip number one, bring a threat model to the table, right? Often, you're starting with, from an enterprise standpoint, a list of requirements. It might be a security requirements traceability matrix. It might be an assurance framework that has particular guidance. What the threat model does is it allows you to operationalize that in the architecture. You can very concretely not only understand, but argue for or against specific controls and their placement around an asset and to justify why that decision was made over another in terms of meeting those control or regulatory objectives. So absolutely bring a threat model to the table when you're starting to layer in your assets and build up this security architecture above the network layer. When we move on to actually fleshing out that application environment, in this case I'm showing you the database layer. Now what you're going to want to do is take those threat models, take those logical information models, look at your security controls, look at those requirements that you have, and begin to really dovetail them at a fine-grained level to start thinking about how your application ought to perform, right? And now you're starting to think about things like, do you have not only multi-availability zone activities going on, but do you have cross-region activities that are appropriate to have in place, whether it's cross-region snapshots, right, or other AWS-provided mechanisms? And also going layers into the environment if you're working in something like RDS where you've got choices around transparent data encryption, network encryption at the database layer, right? Thinking about the transport level encryption between EMR job flows and things of that nature. So here's where all of that preparatory work and thinking about how your AWS deployments fit into that broader enterprise framework really start to come together to make architectures that are not only something that looks nice on paper, but is eminently deployable, right? You can actually code that up and push it out into the AWS environment to run against. And so what you're kind of seeing in this background is a little bit of this idea of you design, you build, and then you operate. One of the layers that gets a particularly high degree of attention when we're engaging with enterprises is this threat management layer. And there's really a couple of different aspects to it. At a broad level, the threat protection layer is where you're going to layer in a number of features and services of what is often considered a management plane in a traditional environment. So, for example, you might want to consider deploying Bastion hosts for privileged users to be able to use as jump boxes into the rest of your environment. And Bill's going to talk a little bit more deeply about how you might configure them and how you might deploy them a little later in our talk. Another thing you might consider in this kind of protection tier is how are you going to deploy your logging infrastructure, right? Your sense and detect infrastructure, your intrusion detection, and your threat management infrastructure. And so you might, for instance, be considering an IDS, IPS type of layer where you've got natting and high availability. And this is an area where organizations will typically start thinking about only protecting the ingress and egress of their organization. So they'll say, where do I have an internet gateway? Let's put the threat protection layer there. And that's certainly a good first start. But as the organization matures and as they start thinking a little more deeply about how they'd like to have enclaves or zones, if that's appropriate for the risk management environment that they're choosing to operate under, they also begin to think about how do you layer up threat management in between those enclaves within their VPC or even across VPCs, regardless of whether the traffic actually traverses an internet gateway, right, and goes back out to the organization or through a direct connect back into their on-premise site. And so what we find is that, again, these layers are flexible, they're agile, and you can configure them independently so that you can tool them and you can scale them as needed based on the performance characteristics of the workloads that they're protecting. Finally, you end up in a situation where you've got your enterprise security architecture, you've got a number of different views, you've got your control mappings, and now you've got a couple of very interesting questions you've got to put on the table for the rest of the organization. First and foremost of which is, well, how am I going to test against this, right? How do I know that the architecture I've developed is properly scoped, it has a sufficiently small attack surface, right? It meets our requirements. And one of the interesting things you can do when thinking about that is begin to engage with your, whether you call them your pen test team or your red team or your quality assurance team. And here's a pro tip for that as well, right? Lead with an IAM policy, right? These guys are likely to be very, very comfortable in user land. So the operating system, the application, how do you test a database, right? How do you test login on an operating system? But the first opportunity to have a real conversation about why this architecture is special, why is it constructed in the way it's seen on paper, is around that governance and that IAM service. And so if you start by helping work them through the evaluation of an IAM policy, right, it gives them an opportunity to think beyond a traditional deployment and think into a service-oriented, API-driven infrastructure as code environment, and begins to inculcate them into the idea that you're testing the infrastructure itself in a way that gives you a whole lot more transparency and accountability and probably isn't in their existing checklists or automated tools, right? So it's a really, really nice place to start to kind of validate that the architecture is going to perform as advertised. What you then might do after you've built your architecture is think about how are you going to operate this, right? So we've got our design, build, and then operate. And what we're finding is across enterprises, security organizations are asking us to help them build security playbooks. Gives them an opportunity to develop a rehearsed set of actions, to automate tasks where appropriate and applicable, and to document their approved configurations in such a way that not only does everybody benefit from essentially on-the-job training, but it gives everybody an opportunity to iterate very quickly and start with a document that over time gets smaller and smaller and smaller, right? Because what you find is that as you dial in your best practices and as you learn more about the way your organization chooses to operate from a security and risk standpoint in the AWS environment, you're pushing more and more of what had been manual or carefully human orchestrated processes into the automation that our APIs provide. And so the human-driven tasks that would be memorialized in that playbook get shorter and shorter and shorter, and you can spend more time dealing with the actual secure operations of the environment, right, than some of the day-to-day decision-making, which eats up a lot of time as undifferentiated heavy lifting. So let's take a little bit of a look at what a security operations playbook does. First of all, it empowers the CISO organization to operate securely, right? It's that playbook that says, we've got a good design, we've got a good strategy, and we know how to operate it effectively. The other thing does is it enables your business partners to secure their deployments and manage mission risk, right? One of the things that will often happen is you'll build a really strong muscle in the security organization, and then you'll go to an enterprise or a business line within the enterprise, and you'll start that kind of do loop of, well, why haven't you secured this to policy? Well, we didn't know how to secure it to policy. Well, we told you what the policy was. Yeah, but we didn't see what the document was. This is a really, really simplistic way to be able to document how you're going to operate on the back end and forward deploy that into your partner and customer environment. One of the interesting stories I have to tell is we were working with a large enterprise customer, and what they were thinking was actually 2 or 3 steps ahead of this. They said, this is really fantastic to have a strategy and a playbook for our own organization. But what we want to be able to do is extend the shared responsibility model from our platform into our customer space outside of the enterprise. And as we talked through it, what we kind of arrived at was this idea that, well, if we've got a strategy that everybody bought into internally, and we've got a playbook that demonstrates we can execute that effectively, gosh, wouldn't it be really awesome to share parts of that with our customers, to give them the confidence in our capability of operating in this environment? And so that's exactly what we did. We essentially produced a summary of their strategy and playbook. And any prospective customer who was interested in using their platform as a service, we made that available to them, right, under NDA, so that not only would they understand the shared responsibility model between AWS and this organization as our customer, but they understood the shared responsibility could be forward deployed or extended between that platform as a service provider and their customers, right? Which in turn allowed that end user to truly understand the level of risk that they would be accepting by engaging with this platform as a service provider, and make it much easier to convince their security organization that this was the right thing to do, the right things had been thought about, and the right things had been implemented. All right? So you get a lot of really nice synergy there. You kind of compound the value of this strategy and this implementation over time. Specifically, what might be in a playbook or a runbook? There's lots of ways to bake one of these things. They can be very, very complex, or they can be very simple. In the AWS environment, as you'll see as I run through a couple of these slides, one of the key aspects of it is it ultimately ends up with implementable artifacts that are automatable. So CloudFormation templates, IAM policies, OpsWorks recipes, right? But it starts very simply, providing an overview of either the AWS service that you're choosing to consume and how you want to consume it, or perhaps a workflow or a business need that you might be driving at, the requirements and dependencies, the actual workflow for operating or deploying, and then any exceptions, right? So that you know what a known good deployment looks like, and you know what the failure conditions are, and you've already thought through how to deal with them. So if you've ever worked in an operational environment, you realize that stuff fails, right? And the value of a playbook in that instance is it doesn't fail with a big question mark, right? It fails into a mode that you've already prepared for, you've already rehearsed, and you're very easily able to accommodate that and move on without impacting your customers. So you might start out with just a simple description of the service, as I mentioned, and describe the goal and objective of why we're doing this particular feature and why it's important from an operational security standpoint. You then move into the control selection, and if you've already mapped them at a high level, what you're really doing here is thinking now about very specific controls within the context of the service and how you choose to deploy them. In this example, since we're using S3, you'd be thinking about what type of controls at a high level are going to be in your IAM access policy. You're going to be thinking about what type of bucket policy you're going to overlay on top of that S3 resource. And then you're thinking about those coarse-grained access control lists that are going to grant simple but broad permissions to the objects within that bucket. You might then take that a step further and actually map the access control lists from those 3 categories into specific policy actions that are derived, right? So this is kind of a logical way of saying we've got lots of possibilities, but based on the particular way we chose to articulate how we're going to run from a strategic standpoint, and based on the patterns that are illustrated in our architecture, these are the very specific tasks and the actions that we expect to occur on deployment. And then finally, you'll memorialize that in code, right, so that you can actually deploy and implement in an automated fashion. Now, one of the really, really cool things about working at AWS is that we're very responsive not only to customer needs, but to the ability to model things out for customers. So you probably heard in the last couple of weeks, we launched a policy simulator. What this does is it's a tool that gives you ability to model out your IAM policies and see how it would react to a given situation prior to deploying it into production, right? So remember earlier I said one of the things you could do when you're trying to validate or verify your architecture, or in this case your playbook, is to engage with your pen test team or your quality assurance team and ask them to evaluate it. And earlier you were probably thinking, well, how are they going to do that? Are they going to have to read it line by line and try to understand what it does? Well, a great way to do that is hand them the policy to read through and then walk them through the policy simulator. Say, this is why we made these certain decisions. This would be the expected outcome, and see here, this is how it responds. And more importantly, if you've got questions about other things we could have done, let's model those out too. Let's look at different scope of access. Let's look at the difference between using groups as opposed to individual permissions, and really think through some of those scenarios till you get a point where everybody is comfortable with the way you're choosing to implement. You might do that then across a number of different aspects. So enforcing SSL, enabling and enforcing server-side encryption, again, talking about what does that security operations playbook look like for a service like S3. And finally, memorialize that entire thing in a CloudFormation template, which would actually reside as part of that playbook. So people could read the decision tree, they could understand the specific tasks that are required, and then in more cases than not, the end result isn't step-by-step implementing this through the CLI, right, or the SDK. It's taking these automated, pre-built, version-controlled, access-controlled templates and pushing them into production in the environment in a very repeatable, very expected way. And so when you do that, you also want to consider some of those exceptions. And here's just a very simple example where you might say there's a particular way we want to deploy things, and there's some anti-patterns that perhaps we want to avoid using around this particular security operation, right? So in this case, what we're saying is maybe let's not use S3 tags to configure permissions or resources. Instead, we're going to use keys and delimiters to create more of a hierarchical or folder-level permissions model over this object-based storage system, right? So this is an area where you can kind of tell people, you know, the reason we're doing it is this particular way. You could go path A, right? But we'd actually prefer you take path B, and here's the reasons why that we have that exception. So the value, again, here is being able to take the things that we've talked about from a strategy and an architecture standpoint and operationalize it in a very crisp way. What we find is that as we deploy across the enterprise, it really does build confidence in their capability of the security operations teams to implement. And we find them carving off portions of the playbook, whether it's the text itself or simply the templates, to push down into their business partners' environments or sometimes sharing with their customers to allow them to replicate that as well, right? To be able to do that in a smaller entity. So what we'll now talk about is taking some of those specific use cases that Bill and I talked about in the mapping and the architecture standpoint, and Bill's going to talk us through some privilege isolation and some role-based deployments.
So we talked about capabilities and mapping the features and functions onto those capabilities. And so we'll take a little bit of a turn of direction and talk about using identity and access management to achieve some operational acceleration of security as well as privilege and trust isolation. We'll go back to some of the themes we talked about around Bastion Hosts, as well as using and thinking about IAM roles ahead of time and planning that out. So when you plan an architecture, thinking about some of the things we can incorporate in here to make security easier and also more secure in a number of different scenarios. So there's a bunch of ways to achieve privilege isolation in Amazon Web Services. You've heard a lot about this week in the security track. This is not a hierarchical model by any sense, even though it kind of looks like one. You can do it all the way at the account level. Some customers have up to hundreds of accounts. And they achieve privilege isolation that way by isolating the resources in completely different AWS accounts, whether that's one for production and one for test and dev, or different accounts for each business line, or maybe even each customer if you're a SaaS provider or an ISV. You can also do that all the way down to security groups at layer 4. So there's certainly traditional network trust boundaries you can achieve with security groups. Everything down to the individual API call. So you saw some examples of identity and access management policies that allow you to control basically each method call or each API call down to an individual user or role. We've added a lot of resource-based permissions as well. Everything down to an individual DynamoDB row or individual security groups or things in EC2 that can now take per resource permission. So based on a tag, you can set a condition that says this person can only take action against this resource with a certain label. So we'll do a quick refresher on identity and access management as well. So the security token service is something that exists in AWS. Most people might not be aware of it. Many people might not be aware of it. It's kind of there helping with the authentication and authorization. So there's a function in the security token service called assume role. And it's an API call that allows you to get a set of credentials that assume the entitlements of a role when those credentials are used. So you predefine a role and say anybody in this role or any EC2 instance in a role can take certain actions. And so the security token service will vend a token, basically a access ID, secret, and rotating token. Optionally, for an hour, you can set the duration of the token, and the use of that token will inherit the privileges of that role. So we'll refresh. We'll just show some building blocks that we can then operationalize. Privilege isolation at the resource level. So I briefly mentioned this. This is a lot of information to put on one slide, so we included a link. It's a good place to start to find out how you can achieve individual resource permissions for across the different services by API call. So some API calls support different resource-based permissions, and per service we have information in the documentation about what supports resource-based permissions, and we're expanding that all the time. So it's very exciting. You can think about, in a traditional environment, maybe a rack, you lock it with a key, and you have to give the key to a certain person. We've extended resource-based permissions onto things that traditionally required locks and keys, which I think is pretty innovative and interesting when you think about being able to give that fine-grained, least privilege access all the way down into the infrastructure, up and down the stack. So you can do things like limiting where an application can write to a specific queue. You can talk about a specific parameter group in RDS or Redshift and limit exactly who or which role can take actions on those particular resources. So identity and access management roles for EC2. I spend a lot of time on the phone or on site with customers and get kind of excited about this topic. It's one of the most innovative things we're very proud of. I think it solves a lot of application programming problems as well as key distribution problems. So if I'm on the phone with you, and maybe I have been, hopefully I have, then if I don't mention this, then maybe I should have. So now's the chance. So use IAM roles, please. Really want people to start adopting this. When you launch an EC2 instance, if it needs access to, if anything on that, an application or a user needs access to the AWS APIs in the way you're building your application, try to use AWS roles and see if that's the right fit. It solves several problems we'll talk about in the context of security operations. Basically, you give an identity to the instance itself, and using some of the building blocks I previously mentioned, STS, IAM, you're able to launch an EC2 instance into an instance profile that has a role associated with it and a policy as part of that role. And then it's available to all the applications and users on that EC2 instance. The token is vended up through the metadata service, or the EC2 instance metadata service, and all of our SDKs support that in the way they look for credentials. So when you're making an AWS API call, the SDKs look in the metadata service on EC2 instances for security token service credentials, and they can use those without you writing a lick of code, which is a great way for developers to get more efficient, focus on business features, and reduce the need for secrets. So I mentioned briefly the metadata service. It allows you to get credentials out of it and assume the entitlements of the role. Now think about, it's also managing the rotation. So part of the metadata service and the security token service working together, what they're doing is they're rotating those credentials constantly. So think about when you have database credentials, right? You write an application, say it needs to write to Dynamo, right? Instead of managing the credentials in a configuration file, you can use a role to give you entitlements to a particular DynamoDB table, and then the security token service will rotate that, and your application can use it natively with the SDKs. So you never have to distribute secrets for that particular database call. It solves quite a few problems around routing secrets into your applications or having to keep them in source code repositories or keep them in configuration files. So it's reducing attack surface, it's reducing the number of secrets, simplifying automation and application development. So let's talk about a Bastion host configuration. When Hart was mentioning a defense in depth architecture, Bastion hosts for users to log into is a great way to separate trust from an untrusted network into the more sensitive portions of your architecture or your design. So using Bastion host configurations with EC2 roles allows you to do some pretty interesting things. So one of the things we talk about with customers is you can't attack what's not there. So using either auto-scaling or when you have a change request or a break fix operation where an administrator needs to actually log in and do something with the Amazon APIs, nothing should exist until that situation is true, right? So stand up a Bastion host using a CloudFormation template, associate it with a change record or a ticket if you have those kind of controls in your organization, and then when you're done, tear the Bastion host down. Also, you don't need to actually give that administrator any AWS credentials at all that would persist or be long-running or that they would constantly maintain. So if an administrator needs to leave the company for some reason, they take another opportunity, then they don't have credentials. You don't need to give it to them. They simply log into the Bastion host using standard operating system authentication. So if it's tied to your LDAP, if it's tied to Active Directory, they log in, then they're using the role entitlements of the EC2 instance to take actions against the Amazon API. So think about changing security groups, right? Rather than doing that from a laptop, do it from a Bastion host that only exists when you need to change security groups. So there's nothing there to, there's no long-running attack surface at all. So also you can control access by host or purpose. So we talked about IAM policies that are purpose-built. So if you only need to change security groups, or you only need to copy EBS volumes, for example, have a policy that only allows an administrator or an application or set of scripts to copy EBS volumes or change security groups, and then apply that policy to the role, and then instantiate the host into the role. So it's just all about enforcing least privilege access in this particular case. But think about how that maps back to the capabilities framework we talked about. Or if you're working in an audit role or trying to, say, submit control artifacts into your governance, risk, and compliance suite of tools, whether that's an Excel spreadsheet or something more commercial grade, documenting this in a playbook and giving that to your auditors or your risk managers or your compliance folks is a kind of a clean way to show that you're actually meeting your capabilities that we talked about earlier. So as a security practitioner, having an API-driven architecture allows you to do kind of interesting things. There's been this, the long-running discussion between Unix admins who love having root, and they don't want to necessarily give up access to the security team. So how do you do that? How do you provision access to the security team to do their auditing functions without giving them privileged access to the environment? So using a Bastion host or using a security role for an EC2 instance to allow the security team to do their job more effectively is what we're going to talk about here. So when you run a log management suite, or you run a security detective control, operations team or something, you run a SOC, say, for example. One of the more challenging problems in traditional environments is knowing what you're managing and making sure that you are securing everything that's out there. You can't secure what you don't manage. So being able to audit the environment and have a census view of that environment at any given time, running describe calls every 5 minutes if you want to know the state of every given asset in EC2, running describe calls on EBS volumes to know where your sensitive data is all the time. A security practitioner wants to know that information. So being able to get that census picture and feed your SIM tools or feed your scanning and vulnerability management tools is something you might want to do from a security auditing Bastion host. Now, what you can do is also do change detection of vital objects. So using things like CloudTrail helps you know when things change, but you also might want to know what it looked like before it changed. So doing describe calls on sensitive objects, so IAM users, the roles I'm talking about, security groups, critical EBS volumes, just describing those periodically, storing that and then keeping the deltas so you know what changed, not just when it changed. So this is a read-only policy, very simple, just an example of kind of a read-only policy for EC2. So the example I mentioned of a security operations team who needs to know what's in the environment so they can reconcile it with the SIM system or security event management platform and know you're getting logs from all the right systems that you should be. This is all you really need to do in terms of capabilities around the APIs. So the security team or script acting on their behalf would only need these rights to know what the firewall rules are, security group rules, what the network interfaces are in the VPC, as well as what the images are and what instances are running. And you get all that metadata back, and you know that you're managing all the things you should be managing. Another example would be, say, a RDS read-only role, right? So you have a database auditing team or a set of applications and functions that needs to get information about what's happening in RDS. So you can set up database logging parameters in RDS. Let's take MySQL, for example. You can turn on the general log. You can turn on a variety of logs to be able to know what kind of queries are being written. So if you need to know who's accessing your sensitive data, you can get this in the logs on RDS and then have the security team get it out of RDS by a simple policy that allows them to do only that and then pull that into a SIM tool or a log management suite so they know what queries are being run by who and when. But again, it separates the function. This has an additional condition on it, this policy, where you can see that this person, or this role rather, and the instances launched into it can only access the logs from environments from, let's say, prod or DR. So what to do after reInvent? So when all the fun is over in Vegas and it's time to go home, what are some things that you can do to take all of this stuff we've talked about today and really put it to work for you? So update your security strategy and vision. This means thinking about who to work with in the organization, who has accountability for security, and how can you take the capability matrix we showed you and demonstrate to them that here's how we can functionally take what we're familiar with today and bring it into AWS. You can integrate AWS in your security operations, which means things like writing playbooks, as well as talking to your security operations center about how to leverage some of the features like Bastion Hosts and bringing those things into your operating environment. Enable IAM auditing rules. So if you have a security audit function, you have a monitoring team who needs to access AWS, start looking at EC2 roles. We're constantly releasing features around IAM. And it's one of the things that I think really is a game changer for security teams who've struggled to get work done in the past. It really speeds things up, makes things easier for them. So a couple references that we want you to be aware of. These are things we always talk about on the phone. Salespeople talk about them. They're great places to start in becoming more familiar with all the security features and functions within AWS. So the slides we showed with all the security features mapped to capabilities probably won't fit on a slide next year if we're lucky. We keep adding security features at a pretty high rate. The number that I think we showed this morning, over 200 features across AWS, a significant portion of those were security-related or identity-related features that make security easier on AWS than in a traditional environment. So where do you get the latest information? I get asked that a lot. The security blog is a great place. We not only release when we release features, we post the features to the security blog, but there's a lot of how-tos, a lot of guest articles, and a lot of guest authors that will write on there from the service teams, which is a great way to see how the service teams and the people who build the products are thinking about security for our customers. The compliance and security centers both have white papers. We have a brand new or freshly updated security best practices white paper that takes into account a lot more in the past year than, and it's updated and quite popular already. These are the related sessions that I think they're all still remaining. So rather than do Q&A, there's a open 2-hour office hours called Come Talk Security with AWS in Toscana 3605. So there'll be actually members of the service teams there, the Identity and Access Management team, and other service team members there. And then I think Hart and I will head over there as well to take questions. Really 2 hours, sit down one-on-one, or just come one, come all. And then the other tracks in the security track that are remaining today and tomorrow are listed as well. So thank you very much.